Alright, now let's look at this problem. This problem now involves all words, no events A and B. So we're going to have to figure out what events A and B are. Okay. Alright, on a particular day there is a 40% chance of rain and a 30% chance of no clouds. Alright, in the back of our mind we'll remember that no here, and that sounds like a compliment, right? Note that the probability of rain if there are no clouds in the sky is 0. That sounds like a condition. If there are clouds in the sky, what is the probability of rain? What is the probability of clouds if it is raining? What is the probability of clouds if it is not raining? What's the probability that it is not raining if there are clouds? All right, all sounds like conditional probabilities. Are rain and clouds mutually exclusive? Are no clouds and rain mutually exclusive? Rain and clouds independent? Okay, etc. Okay, it's pretty plain from this one, since it's pretty short and sweet, that we talking about rain and no rain, clouds and no clouds. So let's have event A be rain and B be clouds. Alright, so what we're given is the probability of A is equal to 40%, 0.4. Probability of no clouds, B bar, is 0.3. And we're asked to note that there's a probability of rain, it's A, if there are no clouds, given B bar, is equal to 0. Okay, so we have our 3 items, and then we should be able to complete the rest of the table. Alright, so let's write up our table. A bar, B bar. Alright, probability of A, 0.4, therefore A bar, 0.6. Probability of B bar is 0.3, and therefore B be 0.7. And we're given the probability of A given B bar is 0. So let's write out a multiplication rule which will incorporate that. So the probability of those two events, A and B bar, will be equal to the probability of something times the probability of A given B bar. Alright, since B bar is conditioned over there, it'll be probability of B bar. Probability of B bar is 0.3 times 0, and of course that's 0, so probability of A and B bar is 0. So that item is 0. Okay, so then we can fill out the rest. Okay, and there's our table. Alright, let's now have a look at these questions. Alright, part A, if there are clouds in the sky, what's the probability of rain? So that's probability of rain is A, if there are clouds in the sky, given B, is what we're looking for. Alright, so A is the probability of A given B. Alright, the formula that will do that will be the probability of A and B on the top divided by the probability of B, since it's conditioned, B is conditioned on the left. Probability of A and B from the table, 0.4 divided by the probability of B, 0.7. Alright, and my calculations tell me that that's 0.5714 to 4 significant places. Alright, so that's part A. Part B, what is the probability of clouds if it is raining? Probability of clouds B, given that it is raining. Right, B given A. again, write down a formula that incorporates that. That's the two events A and B divided by the whatever's conditioned on the left-hand side, A and B again is 0.4 divided by the probability of A. 0.4 is 1. 100% probability that there are clouds in the sky if it's raining. Well, we should have known that, right? Can't rain without clouds. That's 100% probability. All right, C. What is the probability of clouds if it is not raining? Probability clouds given no rain. All right, probability of B given A bar. Probability of B given A bar. And writing out a formula again, those two events with an and, A bar and B, divided by the probability of whatever it's conditioned on the left, that's A bar. Oops. Alright, A bar and B. A bar and B is the 0.3. Alright, divided by A bar, which is 0.6. That's a half. Alright, so it's 50% chance of, sorry, wrong one. 50% chance of clouds if it is not raining is part C. Okay, so I'm losing my place there. All right, D. What is the probability that it is not raining? Not raining. A bar given if there are clouds. All right, if there are clouds. So there's A bar given B. A again. All right, so probability of A bar and B divided by the probability of B. Okay, so we'll go back to our table. That's not it. A bar and B is 0.3. Divided by probability of B, 0.7. Alright, and my calculations tell me that's 0.4286 to 4 significant places. Notice that that question, part D, was the complement of part A. Alright, since they're both conditioned on B, and the first parts, A and A bar, are complements, therefore those two events are complements.